Okay, today I'll talk about Boolean expressions, order of precedence for Boolean expressions, and we'll go over a couple of examples, like maybe three or four, just to make sure that you'll understand instead of guessing, right? 'Cause sometimes in the assignments, I see students guessing a lot, and it's kind of like, well, I mean, if you just if you just know how they work, then you don't have to be guessing. Okay, so let's go over a few of them. So we want to determine if in range 1 to 10, and we accept a number. So we just want to check if on any number we use as a function argument, is it in the range of 1 to 10? Let's go to this one, open close curly brace, and we can say we want to return. So then we want to say, okay, we need two expressions, right? Because we need to compare if it's greater than or equal to 1, but then we also need to check if it's less than and equal to 10. So then we need to say greater than or equal to 1 and actually num, right? Not in. In my brain, I was thinking n for number. Okay, so less than equal to 10. And how is this evaluated? So this one's evaluated. So if num is not greater than 1, then it's false, right? And then this one doesn't even have to be compared because, well, I mean, if it's 0, then it's not gonna be in range, right? Or anything less than 1. Okay, so we can go to test cases and then we can just enter different assertions to make sure that our stuff's gonna work. Not homework, examples. Okay, examples mod 3, and then we come here and then we can to 10 and so here we can create the assertion require require, and we already have if in there, so we should be able to say as long as I can remember the name of that function, is in range. Okay, is in range 0, and we know for a fact that that one should not be in range, and 11 should not be in range, but anything else like number 5 should be in range, right? So notice right here we have our test case and we can run it. So we can go here and run our test case. And then what we'll do next is we'll check if a number is not in range, like, and there's two different options. Like we can use that same code we have here, like we can use the same code and we can just not it, right? I mean, it'll be the inverse. So I mean, this, we know this, once a test case passes, hopefully, then we'll know, hey, this code works for in range. So if we not it, meaning if we say not this, then it'll be not in range. That's one way, or we can just find another way, right? So let me see here what happens. So number 1 greater than equal to 1 and number less than equal to 10 equals false. Okay, let me verify that. 5 greater equal 1? True. Oh, I put false. Okay. Yeah. So I put false. Okay. So I was going to walk through it, but the code is correct. It's just my data for testing is wrong. Okay. So I was already going to walk through it. So then we come back here and then it should be okay. So then we come back to the source code. Close switch, main, if, okay. So I was saying like this should be okay for in range. So then I said linking once it starts linking, because sometimes when I start typing, then it freaks it out. So then, okay. So then we'll say it's not in range 1 to 10, and then we'll use a number. So again, we could have done this in main, but it's always better just to practice. Actually, this is okay here, and over here we write some code. Okay, so what I was saying, so everything passes, up arrow space dash S enter. So we're good. Like 11 is not in range, 5 is in range, and well, 0 is not in range, right? Because, well, we know it passed because there's no red marks. Okay, so not in range, we can easily say, well, we can not this. And as long as we close the parentheses, then we should be okay. So now what we are saying is first we do this, right? So if we say 11, well, 11 here in this case is going to be false because 11 it is greater than 1, but it's not less than 10. So this is false, but then we're saying not. So then it'll be converted to true, and that will work. So we can come to this test case. Not. Okay, so we can say require is not in range. So then this one now should be true. This one should be false as long as we change it to 5. So now it's the opposite, right? And this one should be true as long as it's 11. So here we had false, true, false. Now over here we have true, false, true. And what we're doing is we know already that this is for in range. So now we're just going to not this piece just to do not in range. That's one way of doing it. And then we can run our code. So we come here and we run our code. So one thing sometimes I see students do is I see them change this here. Like they say, well, num less than or equal 1 and num greater than or equal to 10. But that won't work because like 0 is not in range, right? But let me see here what happened. I wonder why that happens sometimes. Build. Okay, run. Okay, so we're still passing. So notice not in range. So it passed, and let me. Not in range and not in range. So it works because of the understanding of the not symbol, right? But what if the professor's like, well, find not in range using OR, right? Here there was no requirements, but what if it's like, well, okay, so do not in range but using OR. Okay, let me finish that thought, right? So sometimes students, when they're trying to do not in range, they change this to less than, and then they change this to greater than. But remember how AND works. For it to be true, the two options have to be true. And a number cannot, like if it's 0, yeah, it is less than 1, but it'll never, ever until the end of time, it'll never be greater than 10. And then, like 11 is greater than 10, but it'll never, ever be less than 1. So that's where we can use that logic. And I've seen, I don't know, I guess maybe it's like a lack of understanding, or I didn't explain well, but just remember, like, if you understand how AND works, the truth tables, what are the truth tables? This one's, if you, conditional structure, if you know these truth tables, so when you're using AND, then you should know that the only way an AND compound statement will be true is if both are true. Okay, so that's what I'm saying. Like, I think students don't know the truth table. That's why they do, well, I mean, not in range, then it'll be less than, and then over here, I just make it to greater than. But I mean, if you really think about it, that'll never work because a number cannot be less than 0 and greater than 10, like never, to determine if it's in range or not in range. Okay, so what do we want to do this same not in range but with OR? So then let me go to the .h. So with OR. Okay, so we come back here. And we can return. So now if we go back to the truth table, so now we know here, notice here how it works. So if either one of them is true, then it's true. Here, both of them are true, right? So now we can go back and be like, oh, okay, so maybe now I can use that logic. I can say if number less than 1 or number greater than 10, then that will solve my problem, right? So, okay, let's test, so not in range, let's test 0. Is 0 greater than 1? No. Is 0 greater than 10? No. Okay, and then we can do 11. So is 11 not, and is 11 greater? Okay. I think, sorry, this is wrong. See, I talked myself out of it. Okay, so now this is right. Okay, 0. Is 0 less than 1? True. So now I don't even have to check the right part, right? Because from the truth table, I know that if 1 is true, then that's it, like it's true. Now we can do 11. So is 11 less than 1? No. Is 11 greater than 10? Yes. So 0 and 11 are not in range, and this is the correct statement for not in range using OR. And we can verify that with a test case. So we can come here. And remember, this string right here has to be different for every test case. If it's not, then your test cases will not run. So please don't forget that. Open close curly brace. Require is not in range or, so when we say actually this is what not in range true. Not in range, so this one should be false, right? And this one should be true. Okay, let's do 5, okay? Is 5 less than 1? False. Is 5 greater than 10? False, right? So the yeah, the exclamation point is not, like this one is not, right? So if you recall from the notes here, right? So not is not, the exclamation point. Okay, so let's run this, see what happens. Like these are very simple problems. The main, or my main concern here, my main concept I want students to learn is the truth table. With the truth table, then you don't have to be guessing. Like you don't have to be guessing, like I said, and learn the truth table, and then when you format the Boolean expressions, then you'll know how to set them up. Watch it fail. Should pass. Right, so all tests passed with little help from the truth tables, right? So we're good. Okay, so what if we want to test a character, and we want to see if that character is a consonant. That's what we want. We want to test if a character is a consonant. Okay, so we come here. Bool. Actually, let me do it on H first. Okay, so bool is character character A. How do you spell consonant? Consonant, like that. Whatever, good enough. I didn't do too well in grammar or in English, so let me see. I think it's with an A, no? Is it an A? I don't know. We can, whatever. I think it is an A. And that looks weird, but oh well. Let me ask my friend Google. Oh, that is correct. I don't know why it looked wrong. Okay. Okay, so is character a consonant? Okay, so how do we do this? Anyone? Like, how should we tackle this one? Consonant, okay. Yeah. Okay, so there we go, right? So first we need to determine if it's a vowel because there's 5 vowels. So instead of writing like 21 ors, then we can narrow that down to 5. So we can say so first, the first thing I do is C equal A or C equals E or C equals I or C equals O, C equals U. But that tells me if it's a vowel. So then what do I need to do here? Yeah, so now we use not, right? So first we find out is it a vowel, but then we not that. And if we not that with the exclamation point like this, then now we'll get the correct answer, right? Because if it's not a vowel, then this is going to be false. This is going to be false, so then we not it and we convert it to true, right? So we do the inverse. And we can always count on our test cases to help us. Yeah, so sometimes students, for some reason, they struggle with this, right? So consonant. Okay. So we require what did I name it? Is car const. Okay. So A we know should be false. B should be true. And then we can run this. Also, the order of operations, meaning like if you have a compound statement that has nots, ands, and ors, not takes precedence and followed by and finally or. Okay, so that way sometimes you have to write like different different Boolean expressions to get like one final one, and you have to use all three. You have to remember that not takes precedence. Okay, so. Okay, so we're still good. Open space, / enter. So B is a consonant. A is not a consonant, right? So our statement is correct, and we can run a couple of more just to make sure. Like we can try E. That one should be false, and then we can try some other letter like T. That one should be true, and we should be okay. Why? Because first we determine if it's a vowel, and then we get the inverse, right? The inverse operation. Okay, let me see if I have something else here for this piece. Yeah, the only other thing is just make sure that you know this is or, exclamation point is not, double ampersand is and, okay? And then you should be ready for the quiz. Yeah, so we're still good. So so this function is also working, right? So now we can comfortably use them in main. We're not right now, right? But we could use them in main and we'd be okay. Yeah, so a character is only one. It's only one character. We cannot have like two. It's only one at any one time. If we try to do two, then we'll run into issues. So anytime we're working with characters, we use single quotes. Anytime we're using strings, we have to use double quotes. Yeah, that's a good question. Okay, so on last week's examples, I don't think I created a main for this one, for the if-else. We'll create one right now. Oh, let me see. I don't think I did for this class, right? This source code is for the last class. So let me close this one. I'm pretty sure I didn't for this class. I should be working on this one. Okay. Yeah, so for this class, I'm pretty sure I didn't. So I'll briefly do them. So write code to capture year from the keyboard, pass year to get generation function, and display the results. Okay, so this was for that get generation code that we had, where we were accepting a year, and then we were determining the generation from that year, if possible. So briefly here, so auto year, auto, just so that I can show you that we can use auto. We do have to set a value, a whole number, to make this an integer. So notice int, int year, integer year. Cout, enter year. Cin year, so that one captures the year from the keyboard. And then we say auto generation equals get generation, and we use year as the function argument. And then we say, we're not going to worry about the invalid, okay? We'll just say generation is, and if it's invalid, oh well, we'll display invalid. Generation is generation. Okay. So we go here to CMake, SRC, examples 3. Yeah, one thing you can also do if you want to, you can, let me see here. You can hit this run at the bottom, and then you can scroll to what you want to run, right? Like if I wanted to run this one, then I have to go to 0102, so 0102, and then it runs 0103, sorry, 0103. 0103. You see, you can scroll and then select 0302 302. Okay, 0302, 0302, and then you see it selects it down here, EX0302, and then you can hit run here, and then it asks me to enter year. I'll use like 1926 and silent generation, up arrow, enter 1990 millennial, up arrow, enter 2021, invalid year. So our code is good. Yeah, it can be for it can be for the executable, right? And it's also for the test cases. You just have to scroll and find them. So okay, now we do main for any questions here. Like we've done this, right? Like year, prompt the user if we want something from them. Otherwise, they may not know. Capture year, and then we call get generation, set it to a local variable, use the local variable to output the value. Okay, so we go to switch now, main, and what do we have in switch? We have the options. Okay, so this one's pretty easy. We can say using cin, using cout, auto option equals 0, prompt the user, enter option. And I mean, we want to be helpful, we can say like 1, 2, 4, something like that, right? Or we can even be more explicit and create a menu for them, but for now 1 to 4 should be okay. And then capture from keyboard, and then doesn't know what I'm talking about because I need to come up here and include switch.h menu, and then I use option that I captured from keyboard, and then I simply say, oops, not that, this, right, to output the variable result. And then I can go ahead and run this, run in terminal, enter option 3, so option 3, up arrow, run again, 5, invalid option, run again, 0, invalid option, 1, option 1, right? So my code works, and we knew it was going to work because we tested this menu function with test cases to make sure it worked properly, and we can use it with confidence now. So that's what it's all about. Yeah, so if the user enters letters, well, actually, it might convert it to a number, right? If it's one letter. But we'll talk about validating input in the near future. But for now, our users are perfect. They always give us what we expect. Okay, so let me close all this. And let me save this. So if else if main switch main stage commit push. Okay. So always put meaningful comments in GitHub, right? Because let me show you my GitHub. As your GitHub grows with commits, it's the breadcrumbs for what you've done in this class, right? So let me go here. I hit commits here, and notice like I'm trying to give myself as much information to refer back to this code later. If else if main, switch main, if else if switch. So what I worked on, right? And that way, as students ask me, then I can just go and point them to a date. Or you can come to my repository and click on commits here, and then you can find what you need, hit this link, and then you can see the code as I checked it in. Okay, so also always try to check in, like for homework 1, make one commit as homework 1, unless you're like, you made errors and then you came back and fixed it. I guess that's fine. But usually like you want to make them like this, like everything's related to this. So like if I say homework 1, then this code should only be related to homework 1, because it'll help you in the future, like if you need to come back and fix bugs, right? Not for your homework, but if you're programming out there in the industry. Okay, so we jump to loops. So we talked about conditional structures, and more or less work like Python, except for that different one, the switch. But once you go through it, then it's not that difficult to learn, right? Maybe the syntax, but other than that, I mean, it shouldn't be that hard. So now we jump to loop. So in C++, we have, just like in Python, you go here. So we have the while loop, the for loop. We have a do while, and we also have a range for, or a for range loop. This for range is the one you use for Python, like when you would iterate a list. If the list name was friends, and then you could go like for, I don't remember the syntax, right? But for friend in friends. So then friend was the current friend in the loop. And then you would do something with that. The loop would come back around, and then you could do something with the next friend. So this is modern C++ trying to compete with those guys. Okay, so we come back to code, and recall that I was talking about CMake and how we have modules 1, 2, 3 open for compilation, but not 4. Well, here we're jumping into 4. So if you are following along with me, then we have to unlock or remove this comment from SRC examples, CMake list, and we have to do the same thing to test examples, CMake list, because we want to be able to run the test cases. Okay, so that should allow me to compile module 4 code. So then I can come here, and then I see what we have. Take a drink. Thirsty. Yeah, the cold tricks you into thinking you don't need water. Okay, so what do we have here? Write a function prototype named sum of squares that accepts an int and returns an int. Okay, so returns an int, sum of squares, accepts an int, number. So if you were doing this exercise in Python, then you did it in main. But I think they may have done like some from 1 through 5. So then you would do 1 plus 2 and then plus 3 plus 4 plus 5, right? But in main. So here we're doing the same thing, but in a function. And then we will test it. And then finally we'll use it in main. Okay, so we come here and, oops, Control V. I didn't even know Control B was that, but now I know. Okay, using a while loop, write code for sum of squares that accepts an integer returns the sum of all the squares of that number from 1 to the number. So including the number, right? So 1 times 1 plus 2 times 2 plus 3 times 3 plus 4 times 4 equals 30. Okay, so that's what we want to write, but it has to work for any number, not just for 4. Okay, so that's why we have this number here. Okay, so I'll do the easy part. And we probably need sum, so we set it to 0. And I'll make sure I put return down here. That way I don't forget to return it. So we need to iterate from 1 to 4 or from 4 to in reverse, like whichever way, it doesn't matter. So what do we need? I think that's my job saying that our offices are closed tomorrow. Downtown, I hope so. Okay, so anyone like want to help me out here? Say again? No, I haven't gone since last year. No. But they still close the office because I think some employees go. Like the attorneys, I think they have to be there. So, uh, okay. So let's think of this. We have to iterate either from 1 to 4 or from 4 to 1, including 1. So how would we do that? So we need a range. So we do need a range, but we need to use a while loop, right? So that tells me that we need a number to help us keep track of where we are. So we can say, so we can start the index at 1, right? Since and then we need to compare the index to something. So right, because we need a condition. So we need to loop from 1 to 4. So how would I set up the Boolean expression here in the while loop? Mm-hmm. Well, we want it to work for any number, so it would be num, right? But that's the right idea. So then to num, yeah. Okay, so now we can say sum equals to what? Oh, okay. So this is what we want to do, right? So we know n is 4 and index is 1. So we need to derive at this calculation somehow, and then we need to save it into sum. So that's why we can say sum equal to sum plus something. Let me see here. Num1 times num2, num times num. Okay, so if I call this function in a test case, I'll call it like this. Oops, I'll say sum of squares 4. So num is 4. So I can't say num times num because then I'll always be doing 4 times 4. The way we've set up the problem right now. But what other number can we use? Maybe this guy here, right? Because the index is going to be 1, and then we do sum equals sum plus index times index. And then we need to add 1 to the index, right? Because we're saying while index less than equal to 1. So recall in the while loop, in the code, we need to modify a variable to eventually make this condition false. And then once that happens, then the loop stops executing. So we can say index equal index plus 1. Or in C++, you can say index plus plus, and that adds 1 to the value of index. And that was something that is here actually in expressions, right? But I didn't really have a good example for it, but now this is a good example, okay? And so we use it. So this is the same as index equals index plus 1. In Python, you probably did index plus equal 1, but C++ has the plus plus or unary incrementer, and this will add 1 too. So will this code work? We always have our test case to fall back on, right? So, man, these people, that number looks like from the office. Okay, so let's go to the test case. One good thing about the test case is we'll know right away, like, we'll know if our code's working or not. So include, what file are we looking for? While.h. What's going on here? Hopefully that goes away because there shouldn't be. Oh, I know what. We go here. So I modified the CMake list and notice that module 4 is not here. So I need to click on this guy, configure projects. Once I do that, then it'll scan my CMake list files again, and module 4 will appear here. And then this guys will go away. Okay. Test case. Okay, so require sum of squares 4 equal 30. Okay, so that's one test. And we can go to the test case, test examples, module 4, and we run it. And then we let the test cases guide us. If it fails, then we go back and see what I did wrong, right? Because nobody wanted to help me. You all left me alone on this one. it's building. Okay, so up arrow space dash s enter, so says it's true. So let's do like number 5, so that would be 5 times 5, 25 plus 30. That should be 55. So let's test. Yeah, so it said it passed, right? So now we will test with, sorry about that, with 5, which should be 5 times 5, 25 plus 30, 55, right? So 55, we run that test case. One thing you should never do as a programmer is trust yourself, right? So that's where we use test cases. Once we are backed by test cases, then we have more confidence to trust ourselves. And maybe we do the number 3, so that will be 30 minus 16. That will be what, 14, right? 1 plus 4 plus 9. 1 plus 4 plus 9. So we do 3. So that should be 14. 1 plus 4 plus 9. And this will be the last assertion we add to this function. So hopefully by now, you're convinced that test cases are your friend. Mm-hmm. Mm-hmm. Yeah. 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 So we're good. Test cases are passing. So there is one for minus. So let me see. How can we do that, right? So we could say, yeah, you can do it over here. We can go from 4 to 0, right? So then we would say num minus minus, but I don't think I want to do that since we already have this. But we could always say, okay, I'm going from 4 or from any number I get backwards. So then we wouldn't have to create an extra variable, and then we would say, well, num greater than 0. And then we do num times num, and then num minus minus here, and then it'd be going backwards, and it'll produce the same answer. Okay, any questions here? Okay, so no questions. So we go, we have another example for a while. Let's see. A display returns void display, so we can't test this function. Accepts a string, okay. String. So voids usually display the screen or send files out to somewhere, to disk or somewhere else. Okay, so we come back here and we simply want to get a string and display it character by character one line at a time. Okay, so that's what we want to do. So we want to use a while loop also. Okay. So one good thing about the string is it's an object, and we know how long it is if we use str.length, right? So meaning somebody wrote code to count the characters in the string for us. Okay, so we can say while, and what I'll do is, since I need to display there, I'll include the IOStream in the header file. And I do that because that way if I include the header in main, then I don't have to include IOStream in main again, as long as I remember that I did it for this short example. So let me come back here. Okay, so while, also for a string, right? So if you have a string, then you can access characters like this, just like you did in Python. So this gives you access to the first character, and then so knowing that, then we know that in here we can say start cout str some variable there maybe \n, and now we need to. So anyone, how do we finish this off? No. Remember, a function is always waiting for data. Meaning, like for the test case, we'll call, not for the test case, for main, we'll just say like something like this, right? Or somebody will create a string, and if the string is named, then we'll do that. In main, maybe we create the string, and then we prompt the user, like enter your name. And then they enter the name, and then we display one character at a time. But here we're assuming that somebody's going to give us a string. We're not going to say cout or in here or cin. Somebody will give us a string before they call this function. So we have the string, and we want to iterate through the string one character at a time, output the character, create a new line, and then continue on to the next character. That's our goal here. So that's why I was saying, like, for a character, we can access it like this, but this is a literal, like, I mean, I guess I could do this, but I want to use a loop, right? So meaning I need a variable here. Say again? Okay, so index less than string length. I can do this, no? So then in here, what do I use in here? Yeah, it's right here. Yeah, it's right here. Okay, and then I need to increment index, right? Index plus plus. So I don't have to return anything because this is void, and void means I am not returning anything. So then this should be okay. Yeah, right here. So start cout, display the character at index, create a new line, increment the index by 1, and then we'll check again, see if yeah. So length. So say we have Joe, right? So Joe's length is 3, but in programming with sequences, you always start at 0, right? So that's why I set the index to 0. So index will be 0, 1, 2, and then that'll be the 3 characters. So that's why I say less than string.length. So when it's 2, then I don't want to go anymore. because then I'll go beyond the bounds of my string, and then I'll get funky characters, or I may get an error. Right, so for example, the index will be 0, 1, 2, right? Well, for this one, 3, 4, but the length is 1, 2, 3, 4, 5, right? But notice here we only go to 4 because we started 0, so that's why I set the index to 0. And then we can go ahead and run this. Let me see here. We have to go to main. Okay, so go here, here. While that H is there, and then I can simply say display. I won't prompt the user for now. I'll just say stud string name equals Joe, and then I'll say a name. And so that was the question. Where do we get the name from? Well, whoever calls the function has to provide us the string. So that's what we're doing here. And then we can go ahead and run this program. Oops, I didn't want to debug. Running terminal. Ooh, I saw a warning. What was that? Configuring project. JOE, right? So this is from the command to run a program. So this one doesn't count. So notice JOE. So name comes in here, and then we set index to 0. So string is Joe. So str at index 0, J, new line, increment index by 1, get index at 1, O, new line, and then increment index, come back again. That'll be index at 2, which is E, new line, increment index. So now 3 less than 3, no. So then our loop exits, right? So that's why this works. Any questions here? It is not case sensitive. Thought it was, right? So J is not case sensitive. I'm not understanding the question. No. Oh, in C++ it is case sensitive. Like I guess if you wanted to compare, I think that's what you're talking about. If we wanted to compare, like you want to compare name to some other person's name, yes, in case sensitive matters. Yeah. Someone asked why it started. Sure, why it started with E, and as I said, it was this E because this was compressed, collapsed like this, right? So you see, so that's why you see this E, but this E belongs to this command right here, which is the command to run our program. But if I make this bigger, then the E is over here, and now we see JOE. So it's running correctly. Okay, so again, two things here, like learn looping, but I'm sure you were exposed to something like this in Python, where you get the length of the string, and then you can access one at a time, right? So that's all we're doing here. The only thing that might freak some students out is this syntax. But other than that, it looks okay. It should be the same. Okay, so we come back here, and I think that's it for whiles for now. So close others, leave the test case open, come back here, and let's go on to question. Mm-hmm. Well, there are different problems, right? Like here, we are trying to get characters from a sequence of from a string, right? From a sequence of characters. And here, I guess I could start with 0. I mean, 0 times 0 is 0. But I just wanted to save one iteration. So that's why I put it at 1, right? Because we can do, if we start at 0, sum plus index times 0. So it's still 0. So then I might as well just start at 1. Yeah, 2. Yeah. Okay, so come back here. And we go to 4. And what do we have for 4? Okay, void display numbers accepts an integer. So we're not returning anything, so we can't test this one with a test case. Okay, we just simply want to accept the number, and we more or less want to do the same thing, but we just want to display. Say we get the number 5, then we want to display 1, 2, 3, 4, 5 to screen in a line, but using a for loop now. So in C++, so the for loop works like this. So we declare a variable here. And usually we use I, 0, and then a condition here, I less than or equal to num. Oh, we'll say num. And then we'll say the third step here is to manipulate this number or to modify code to eventually make this condition false so that we can quit the loop. So here we can say num plus plus. Okay, so again, create a variable here, condition here, I less than num, and then not num plus plus, sorry, I plus plus, and then increment I. And here, I streams here. Okay, I don't like it here. I want to put it in here. That way it's included in main if I ever use it there. Okay. So now I want to make this happen. This right here, and it shouldn't be that hard, right? So we know we need to character out. And what do we character out? Num or I? I, right? So I, and new line. Do we need to do something to I by any chance? See this guy. Thought I included here. IO stream. Did I include 4.8? Yeah, I did include it. So I++ is here, okay? So that's one tricky thing with this format. Let me try to compile this. What did I miss? Build. Nothing, it's just tricking me. So this is okay. Okay, let's run this. No, this one closes. So we need semicolon here, and just to make C++ more difficult, they decided that we don't need one here. Yeah. Okay, so what's happening here? Nothing, because I don't have a main. Okay, so let me call display numbers and enter a number, create a variable value, and then pass in the value there. Okay. So declare a variable, prompt the user for input, capture the input, and then use that variable val as a function argument for display numbers. Running terminal. Enter a number 5, 0, 1, 2, 3, 4. So we want 1, 2, 3, 4, 5. So there's several ways we could have done this, right? But since we have everything set up, maybe just say I plus 1 here. And doing I plus 1 here does not affect the value of this I because we're just not saving it to I itself. So it's whatever value is evaluated there is displayed and I keeps its current value. So that's what we want. We don't want to modify I in the code block. We are modifying it here already. So it's not a good idea to modify it again in here. But to get the output we want, we just say, well, I mean, I'll just do I plus 1. You didn't have to do this, but usually in C++, or most programming languages, you start with 0, right? So in order to avoid confusion in the future, then maybe this is the best thing for this case, right? So now we have 1, 2, 3, 4, 5. Question? So the while loop, we don't know how many times, usually we don't know how many times it'll iterate, right? With a for loop, we do. Like most of the times before the loop starts, like we know like how many times it'll iterate. Yeah, so this is, yeah, so again, we need to declare a variable. One thing that you all need to understand is this I is only visible in this block. It's not available for us here. Notice I is undefined, so this I only exists between these curly braces. So don't forget that. Okay, and that's the variable scope. Okay, so no, this is the same thing. It won't create problems because we're not using val until after we assign it a good value. So that's why we won't have any issues. Even this one, like, I mean, by the time it's over here, this overwrites line 5, the line 5 value of 0. So, okay, so let's move on to the next one, do while. And this one, I'm pretty sure Python didn't support it, right? The do while. So the do while loop executes at least one time, and it may execute more than one time, but usually it'll always execute one time. Okay, so write void function prototype name prompt user with no parameters. Let me see. Okay, we can do that one. Okay, so I think void prompt user no parameters. So this is one of the few times, and this is just for this example, that we will use cin in the loop. But this is just to show you that we can usually when you're using many programs, like you ask the user like type any key to continue or type E to exit or something like that. So that's what we'll use here. But this one, user opts not to continue. Okay, so we need to set that up. Okay, so we do need to go in here include IOString because we will be using cout, cin. So we come here, and here we can say cout, cin. Okay. So all we will do is we'll say do. So it'll execute it one time, and then while some condition. This is the only time you put a semicolon after a while, okay? In the do while. More confusion, right? So, but that's the only time, like the only time that if you miss the semicolon, then your program will not compile. So in the do while, you do need this semicolon. And notice the while has to be outside of the curly brace, okay? Okay, so we want to use one character, so we can say character choice, and then we can say cout type y to continue and to exit, something like that, right? This doesn't really matter right now. And then we can say, okay, let's get the user option, the user choice, and then we say choice equals y or choice equals capital Y. And notice again, we are working with character, and character is only one character, and we have to use single quotes every single time. So please don't forget that. So this program, it'll just prompt you. We're not really doing anything, right? I just want to show you that it'll run one time. And if the user types N, then it won't. Let me see. Well, choice equals Y or choice equals Y. Okay, so this one should work. And again, this is a void function. It does not return a value. So the only way to test it is by running it from main. But we can go here, include do while prompt user, and let me see. Okay, and choice equal and false, choice equals and false. So that one, anything other than y actually will exit, right? But that's fine. Okay, let me run this. Go here, run in terminal. So type y to continue and to exit. So typing y should continue. So y continues. Typing capital Y should continue. Typing N should exit, and it exits. And up arrow, enter, shift N for capital N, and that one exits too. Actually, anything other than Y will exit, right? So point being is there are times that we want our logic to run at least one time, and then we want to get some input from the user. And this was usually predominant in many programs where we have to display the menu, and then the user can either exit the program right away or make another option for any other menu item in the option in the program. So, questions here? Sure. Yeah, in main, we included the do while.h, and then we simply call prompt user. Yeah, like usually here would be like start program, and then it would show them a menu, which is what I had here for this example, right? Look, run menu. But we don't have time for that example right now, so that's why I opted for this one, prompt user. Yeah, so there is a quiz, and it's the Boolean logic, and it should be available in 1 minute. Yes.